section. It has been stated the side A is there from both the side. If the permissible bending stress is F, find the moment of resistance when the beam section is placed such that the first one is two sides are horizontal, that is the case A. Second, one diagonal is vertical, and also find the ratio of the moments of the resistance of the section in the two directions. Please understood carefully what is given to us and what we have to find out. In this, a single beam which has been given to us, and it is of square, and dimensions of the square has been given to us. Cross sectional area is A into A square. The permissible bending stress is F. What is our intention is to find out the moment of resistance if I will place the beam like this, where the sides are horizontal. One of the side is horizontal, both the sides, one side and the two sides are horizontal. Here another option is one diagonal is vertical, so this diagonal is vertical, so it means another diagonal is horizontal. What will be the moment of resistance? And the next part, find also the ratio of the moments of the resistance of the section of the two section. We have to find out the ratio also. Now case 1. First figure shows the square beam section when the two sides are horizontal. Let M1 is the moment of resistance of the square beam when the two sides are horizontal. We know the equation. M1, one number when the sides are horizontal. F into Z1, because F is same for both the cases has been stated in the data. So Z1 is the section modulus when both the sides are horizontal. Z1 is the I by Y max. A raised to 4 by 12 divided by A by 2, we obtain A cube by 6, that is the Z1, and very simply by putting the value over here we got M1 is equal to F into Z1 is equal to F into A cube by 6. It's very much simple. Now let us go for the case 2. Case 2 says that square beam section where one diagonal is vertical. So let M2 is the moment of resistance of the square beam when one diagonal is vertical. That is nothing but M2 is equal to F into Z2, where Z2 is the section modulus. Intention is to find out the section modulus for a given beam in which the one diagonal is vertical. Formula is remain same, I by Y max. What we have to do right now, see the figure. Figure is this one. We have to find out the section modulus for this. How to find out the section modulus? It is nothing but 2 into BH cube by 12 divided by Y max. What is BH cube? BH cube divided by Y max, it is A over root 2. So if we are referring a moment of inertia of a triangle about its base is BH cube by 12. We know that a triangle and it's about base, moment of inertia is BH cube by 12. There are two triangles. So the value of I is equal to Z is equal to 2 by 12 into root 2A bracket A by root 2 cube BH cube by Y max. So if we are referring the figure previously, precisely refer, this is my B This is my h. So B is this one, a by root 2 plus a by root 2, 2 into a by root 2, that is root 2a, that is B, h cube, that is a by root 2, bh cube by 12. So if I will take on this tabletop, my figure is like this. I am putting my section like this. This is my B, this is my h. So z is equal to I by y max. So this is my y max itself. We found out h is equal to a over root 2 because this is a, this is a. I have to find out this both the sides. If I will say x, then x square plus x square is equal to x square. 2x square is equal to a square. We found out x square is equal to a square by 2. We found out x is equal to a by root 2. So we found out, if you see in this particular figure, this is a by root 2, this is a by root 2, all are a by root 2. So B is equal to a by root 2 plus a by root 2, that is twice into a by root 2, and we achieve root 2a. So z is equal to I by y is equal to, because the two triangles are there, 2 into 1 by 12 bh cube by y, it is nothing but a by root 2. If we are simplifying once again, z is equal to 2 into 1 by 12, b is nothing but root 2a, h is nothing but a by root 2 cube divide by a by root 2. The same thing that we achieve on this PPT. So if you are referring to the PPT on this, 1 by 12 twice root 2a into a by root 2 cube divide by a by root 2, and we simplifying that, we got it is a cube by 6 into root 2, a cube divide by 6 root 2. This is the value of section modulus when one of the diagonal is vertical. So m2 is equal to f into z2. We found out f into a cube by 6 into root 2. Now this is the another moment of resistance obtained. Ratio of moment of resistance of the section into two different position is equal to m1 divided by m2. F a cube by 6 divided by f into a cube by 6 root 2. F is the same. We obtain the answer root 2 1.414 times. What does it mean? It means that moment of resistance of a rectangular or a square section where the side is horizontal is 1.4 times higher than the moment of resistance when I will put that section when one of the diagonal is vertical. That is the meaning of the statement. Now let us proceed for the next problem. These problems, I will read the data first. Prove that the moment of a resistance of a beam of a square section with its diagonal in the plane of bending increased by flattening top and bottom corners as shown in the figure. Also, the moment of resistance is maximum when y is equal to 8a by 9. Also find the percentage increase in the moment of resistance also. These problems you have to solve at your room, at your home. We will discuss much more in the next class, but please understand the data, what the data which has been given to you and what the things you have to do. The question is that a figure refer. In this figure, a square section which is given to you, in which the diagonal is vertical. Now, you have to prove that if instead of this triangle, I will doing this is flat top and flat bottom by cutting down this triangle from the bottom portion as well as the top portion, there will be increase in the moment of resistance. That is the first question which has been asked to you. You have to prove that the moment of resistance is maximum when this distance y is equal to 8a by 9. Also we have to find out the what about the percentage increase in the moment of resistance. Think, try to solve these problems. I will solve this problem in the next session. So in the today's session we learnt about the problems related to the strength of section as well as the unsymmetrical bending. In the next session we will complete this chapter by solving 2 or 3 problems more. Thank you.